of our energy needs throughout the process once we get the energy balance completed. And liquid effluent will also come from the digester, which I don't have an arrow for. But this is part one of our process. It found it a little easier on KimCAD and as well as presenting to keep it as part one, part two, etc. But from there, we will have the anaerobic digester effluent as well as the combusted biogas going into the bioreactor that I mentioned earlier, which will be our tubular bioreactor. And we size it. The production rates of biodiesel, glycerin, and our other products greatly depend on the size of the bioreactor. The reactor is going to be outside. It's and rather large, and I'm not sure of the land area that they would use specifically, but we chose that 10 acres looked like it was take up a pretty good chunk of their property. So we didn't want to make it much bigger than that, but 10 acres would be our production size throughout the rest of our process. So with a 10-acre photobioreactor producing algae, it then moves on to a centrifuge to remove the bulk of the water, and then move on to our crusher that I mentioned earlier, and then remove more of the water in another centrifuge, which will result in a flow of biomass, which can either go back to the digester to produce more methane, or it can often be sold as fertilizer. And our top stream here is the algae and water, which will go onto a separator, and the water can be recycled back to the plant, and the algae will go on to the transesterification process that Eric is involved with.
Yeah, so algae oil then goes to the transesterification reactor. So algae oil will react with methanol, and so they get mixed, heated up to whatever the reaction temperature is going to be set at. Right now I think it's about 120 degrees Celsius. So that would go into a reactor. We've sized the reactors so that the oil is going to be converted about 99% to biodiesel. So from there, you have, coming out the backside, you'll have algae oil, water, methanol, glycerin. I think that's it. So a distillation column can separate the methanol back out and be recycled. Everything else is considerably heavier, so it can easily separate. The glycerin and biodiesel are not miscible, so you don't form two separate layers. So the biodiesel can be pulled off of one, the glycerin can be pulled off the other. And that's the gist of our process. We've made some improvements since then, but I didn't have pictures of those last night. So there are some minor changes, but this is the gist of how our process works, and all three of them go together to make the overall process. So this is supposedly a presentation for the board, but as of now we don't have capital costs. We're still working on determining all of that. From that we'll have operating costs, which we're still working on determining. From all that we can get our biodiesel selling price, which will be based on our operating costs, and that'll tell us if we can be competitive with the current diesel market. But to do that we need operating and cost and whatnot. From that we hope to be able to figure out how many years it's going to take before our plant breaks even from the capital investment. But obviously we need a cost to be able to do that. So everything else is pretty much blank. We're still working on getting costs, and once we have costs we'll have a full presentation for the board of directors. But this is the outline we plan on following. So summarize our results, conclusions, and I think that is it.